Today I want to talk about several stators that we've got in the shop. One of the things we could see here is how full the slot is with the copper wire in the stator core right here. This is a factory rewind that's just been burned and the data's starting to be removed from it. If you notice the second stator here, this is the same stator, but it's not been rewound or cut and burned. And if you notice the slot fill in this stator, it's right up to the top of the wedge, right by the top of the center of the iron here. This particular stator has been rewound. And if you notice inside this core, we've got over 1/4 of an inch of room below the wedge. This is definitely a problem where the motor can overheat, pull higher current, depending on whether the wire size was dropped or whether they have dropped the turn and tried to increase the horsepower without increasing the wire to take care of the extra current that it now produces. Any way you see it, this is a bad deal. Okay. The factory designs the motor with in mind the circular mils per amp of copper. So the copper that's installed in this slot right here is the right amount for the current capacity of the motor with the horsepower rating. The general idea is to keep the copper the same. You never want to decrease the copper in the slot. This is another Baldor stator that has been to another shop and been rewound to a lap winding. If you look at the slots, you can see that there's 1/4 of an inch of room from the top of the core to the wedge. This wedge isn't fully compacted, so it could even be more than that 1/4 of an inch. That's copper reduction that's not there compared to the other two factory wound motors. This motor is going to pull high current. It's going to have either more horsepower because they've dropped a turn, or if it's the same horsepower, they don't have the same amount of copper in it to carry the current that it used to have. So this motor will always run terribly inefficient and as well be very hot and shorten the lifetime of the motor with the insulation system. So if you look at the type of motor this is, with the winding reduced in the amount of copper like this, the efficiency is going to drop dramatically. Your electrical costs are going to go through the ceiling. So in a year's time period, who knows, it could be, depending on the horsepower, $5,000 to $10,000 more in electrical power consumption. So by reducing the copper in the slot, the repair facility was able to rewind this motor quicker, use less copper in it, and probably charge the same amount. You ending up with a much worse design in the motor and being charged a lot more by the power companies to keep the motor running.